All right, how do we start to tackle this problem? Well, first things first, we're looking at circles again here, right? We got a radius. I'm going to go ahead and draw this radius out. Something like that. And what do we know? What are our knowns here? First thing we know is this is a 90-foot radius. What else do we know? They give us a few other knowns here. They give us some street widths, and they also tell us some numbers. We have some variables here that are important. We also have a number there that's important. So what does that have me do? Well, that actually allows me to have a new radius here. We have that number, and then we have that number. We got 12 feet. And 6 feet here, right? So that's that distance. That is that distance. What does that give me? Well, that gives me the ability to create a whole new triangle here. Because really what we're after is stationing along that line. We have a start here and an end here. Oops. And we know that is 90 feet. But now we also can create kind of a new triangle here with a length, because guess what? We now have that distance because we can take 90 feet minus 12. I should do this in the right colors. Minus 12 feet minus 6 feet gives us 72 feet. So now that new red distance is 72 feet. Everybody see how I got that? I'll eliminate that guy to stop the confusion there. And now this is a simple theorem, right? So now we have... Alright, so we're going to finish the last piece of this, which is just applying Pythagorean theorem. So we have... So we know our C distance is 90. 90 squared equals 72 squared plus x squared. X equals square root of 90 squared minus 72 squared. And that's it. All right, moving on to the next problem. This one we got to do a few different operations on, not quite as simple as the last one. So first things first, what do we have here? They are looking for curve lengths. So first things first, we want to just quickly identify exactly what it is that we're looking for. We're going to pretend I can draw in a straight line. So we are looking for that length and that length. And they do give us a few things that are important to start with. So the biggest one that we are trying to figure out is, number one, what are our radiuses? Number two, kind of how big are some of these angles. So let's try to break this down a little bit. So what do we know? Let's figure out what we can know. One thing I see here right off the bat that it highlights something that's a quick and easy win are these two numbers. Okay, so we have two different bearings there, right? Well, if we do the bearing math on that, let's take a peek at what that looks like. So over here on the right, I'm going to draw out kind of what that looks like. We've got a bearing here, and we have another bearing here. So we have north 70 degrees, 13, 18, E. And then we have south 73 degrees, 35 minutes, 44 seconds. So with those two numbers, we can actually very easily calculate that angle. Which also just so happens to be that angle, isn't it? So very quickly we can do that quick calculation. So by adding and subtracting, oops. From 80, we should get 36 degrees, 10 minutes, 58 seconds. That number can go here. Okay, so that starts that. Now we have that number. So now what we can do from that. So now we can actually calculate the radius because we have our known formula for calculating radius based off of an angle and a length, because they did, again, come down here. Oops, not that color. They gave us that length, right? So I really should break this down into steps, shouldn't I? So that's kind of like step one. Step two, let's figure out this radius. Okay, everybody see what we're doing there? That number should come out too. Okay, so now we have that radius that we wanted. And with that, we should be able to do what? So what numbers are we given here? What else is important to note? We have that and that. So the next step would be to just add those radiuses and then work backwards. So now you've got kind of the other way of working this, right? So same thing, we're still going to use that same radius formula, except we're going to add and subtract those radiuses. So we know we have those plus and minus 50. Try to keep this color coding going. And then you should just be able to solve now for that length. So again, working that formula backwards, it should just be as simple as that L equals 2 pi radius times delta over 360. Again, that's just the inverse